So today I'm going to be showing you guys how to build a fully thrust vectoring fighter jet in the style of my Kitten Jet Mark 12 series. They never have any gyros, it's thrust vectoring only, and this one has very good roll, pretty good pitch, and good yaw. They also have quite a few special features, including a cruise control. Well, a simple cruise control. You can toggle on as much or as little thrust as you want, thanks to an accumulator. It also has an air brake for slowing you down when you need to land or other maneuvers. And it has a fuel and ammo system, so we have only 250 seconds worth of fuel, and I believe we've got 100 seconds worth of ammunition and 12 pairs of rockets. And our standard armament is 6 smart cannons and 2 rockets. Come in here for a nice landing. Pop our air brake open. And the fuel and ammo systems recharge and replenish on the ground, so landing is actually pretty important. Anyways, let's get to building one. So we're going to start with our space fighter cockpit, then make the main thrust. We're going to be using all space thrusters for this build because they have a high power to weight efficiency. And they're also compact, which makes them easy to build around. And we're going to have 7 pairs of them, for 14 in total. And we're going to add some sides. Put some 1x2s in here. We're going to replace those with logic later. Shape out our nose a little bit. Then the tail. Next we're going to grab our rotating servos. We're going to put one there, and another 4 blocks up. And the same on the other side. And these are going to be for both our thrust vectoring and our control surfaces. So we'll make our thruster pod first. We'll grab rounded 1x2s and rounded corners. Then copy a thruster over. Then go to our lift and drag section and grab a simple tail fin. Then we'll copy the structure onto each of the servos. And that's our main thrust vectoring. Then we'll grab some big elevators. And some small elevators to make our vertical stabilizers. Next we'll add in the controls. So pitch in the back. The roll controls are already on there. Then on the right side, we put R1 on the green input and clear the red. And on the left side, we put L1 in the red and clear the green. Then we select both of them, bring their speed all the way up to 2, and drop their angle down to 25. And that's so that the tail fin and elevator fin don't hit each other when we're moving around. We don't want that interference. Then we'll do the same controls on here. L1 on the red, R1 on the green, and we just have to bring the speed up for these ones because they're not going to interfere with the tail fins. And then we're going to select our pitch, the servos and the simple tail fins, but not the thruster pods, and copy them up to the front. And then when you have pitch in the front, you have to reverse the controls. And now we'll move on to some wedges. Start working on our aerodynamics. So we'll put some 1x2s here. Then we'll do a bunch of 2x2s. And this is because the rotating servos have very bad drag. You don't want to leave them exposed to the air. Then do vertical stabilizers. Grab some more 2x2s and fill in those gaps. Then some 4x1s up in the very front for our nose. And now we can put on the wings. So I'm going to guess that our center of lift needs to go about here, but we're going to have them 2 wing panels long, so we'll put them like that. Then grab a small wing panel and put that there. And copy this to the other side. And now we can do our yaw thrusters finally. So we'll select our thruster pod and copy that over to the wingtip. And the wingtip ones are a little bit bigger, so we're going to copy some of those blocks. And then we have to attach them with a flat connector. And I usually add a shield piece over the top as well. Then copy that to the other side. And on the right side, the controls are L1. And on the left side, the controls are R1. Next, we'll give it a top and a bottom. Some more 2x4s and wedges. Shape out the bottom. How's that feeling? We're gonna want those downwards. Looks a little bit better too. Speaking of looking better, that'll look better, a little bit more rounded. And now we'll shape out the wings. So I usually start with the wedges. And that looks okay. So now we'll fill in the gaps. Copy that to the other side. Sometimes it does that, it doesn't flip it. Then we'll grab some flat connectors and sneak them in. And this is so that we've got redundant connections, so that if this panel gets shot off, it's not going to drop this panel. And it's just, I started doing it to keep our wings on more. But actually, this already has a redundant connection here, so we really only need them on the tip here, because otherwise it's not connected to the structural blocks. So we can get rid of that one, actually. And I believe... oh, no, we still need a landing gear. So we've got a tube slope 2x2. And a piece of straight suspension that will bring the settings all the way up on. And then for my landing gear, I like to use skis in the front and the friction pads in the back. So copy these over. Copy the spring. Move that back. Then put your friction pads in the bottom here. Okay, now I think we're good to go. So let's check our control surfaces. Everything seems to be in order. Our yaw thrusters are working, letting us taxi on the ground really nice and easy. Now let's see how she flies. Okay, it's pitching up pretty bad on its own right now, but that won't be too hard to fix. In terms of agility, we've got decent roll. Good pitch. Very good pitch. And pretty darn good yaw. But next we're going to fix the aerodynamics and add a piston glitch in to give it more thrust and add in our weapons. Because right now we're only going about 345 miles an hour is our top speed. We can do better than that. So let's start by working on our drag profile a little bit. We're going to grab these wedges and put them into neutral position, because Trailmakers actually calculates the airflows pretty good. So if your wedges are in this orientation, you can picture the air hitting it and being pushed downward, and then that equal and opposite reaction would push the nose upwards. But if they're in this orientation, you can picture the air getting pushed to the side, and then the force goes side to side and cancels each other out. It'll still be adding drag, but it'll nose it down a little bit naturally, whether it's in this orientation or this orientation. But the forces are there, so just by that little change, let's double check. And yeah, we're still pitching up, but not nearly as severe as before. It's almost manageable, but we'll have it perfect by the end. So now we'll add the piston glitch in. We'll select all the blocks in the back here, and move them up 3 spaces. Then we'll select this 2x4. And we've got our 1x2s here already. So we're going to select some of them and make a little U shape. So one on each side, one on the bottom. And that gives us enough room and connection for our pistons. So we'll slide those in there. So we'll go into our configuration, bring the start position to 0, and clear both inputs. And we'll select the block and the thrusters, and put 7 more pairs in. And we need wedges on the front, which will also be used to help our drag, our aerodynamics profile. So we'll put 2x2 wedges like that, and then on the top, we'll do some 2x1s. Then we'll add our weapon attachment. So we'll grab a 2x4s, and make a nice little protrusion like that. Copy our nose cone on and rotate it so it looks nice. And that gives us a mounting place for our weapons. So it's important that your weapons don't go too far back, because if the piston glitch tries to move the weapons into the servo here, it's going to be bad news. So place them as such. And then we're going to do the timings. So we don't need a delay on the first pair. The second pair gets a delay of 0.08. And the third pair gets a delay of 0.16. And the rockets are going to go right on the wingtips for now. And we're going to set them to L2. And now let's take it for another test flight. Okay, right away, our aerodynamics are much better. I'm not touching the controls, and we're staying at pretty much the exact angle that I left it at. So that's ideal. Also, we're going about 400 miles an hour now, so that's over 55 miles an hour faster. Our guns have the good timing. And our rockets are out wide on the wingtips so that there's less chance of them hitting us in the face. They can still happen with the setup, but not as often as if you had them closer in on the wings. I suppose ideally you would put them on the nose, but that looks a little funny to me. Next we'll move on to some of our special features. First we'll make our air brake. So we're going to delete these two 1x2s and replace them with OR gates. We're going to select one and put it on L1, and the other, give it the control R1. And up here, we're going to replace this 1x2 with an AND gate. And connect both of our OR gates to the AND gate. Select the AND gate. Bring its output to -1. And attach it to both sides of our yaw thrusters. So now, when we yaw in both directions at once, it turns off the thrusters and keeps the tail spread open for the air brake. And if our landing gear wasn't glitched in the ground, we could still turn just fine. Then we'll do the cruise control, which is a little simpler. All we need is an accumulator. So, I'll put that back. We're going to replace this 1x2 on the other side. If you're adding logic into something, it's always nice to replace your 1x2s first, because they're the same size and weight. Anyways, we're going to set the accumulator to a minimum of 0. A maximum of 1. And a scale of 0.5. And we're going to have up and down be our controls. And we'll link it into all of our main thrusters. So everything except for the wingtip thrusters. That includes the ones at the back on the servos. Just a bunch of clicking. Now the maneuvering thrusters. I think I got them all. And then we need some way of telling how much thrust we have on. So we'll grab some hue light panels. And we'll attach our accumulator to those as well. Make sure not to select the yaw thrusters when you're doing this, otherwise you're going to have some issues. But now, by pressing up and down the D-pad, we can toggle on as much or as little thrust as we want, and maintain it without having to have our finger on the trigger. So if you want a very specific speed for formation flying or something like that, or if you just want to have a free hand to take a drink of water or something like that, it comes in handy. I actually use it all the time. Like when I'm stopping or beginning a recording, I'll usually throw on my cruise control so that I can just pause the game basically, and my plane will keep flying itself. And that's also why it's important to have the drag profile set up right, otherwise it'll just naturally pitch up on its own and you'll start doing a loop-de-loop, or pitch down and go into the water. But this one flies very straight already, so if you've been building it exactly as I have, you should have a pretty good plane on your hands already. The last features to add will be the fuel and weapon systems, and that'll be a bunch of logic. So if you're not into that, you can probably stop the video now, but if you're into the logic, pay even more attention. So we'll start by doing our fuel system, and we're going to install that in the back in our piston glitch here in this kind of open space. So first we'll gather all the blocks we need. We'll get an accumulator, an OR gate, an AND gate, and a NOR gate. Then 2 comparison gates, and we might as well grab them now while we're at it. We're going to put in 4 tone generators. You don't necessarily need 4, but I tend to play with my music a little bit loud, so in order to hear the fuel alarms and such, I use 4. So now we'll set up the programming. We'll bring the minimum to 0 on the accumulator. Keep the maximum at 100. And the scale will be what determines how much fuel we have. So if we have a scale of 1, we'll have 100 seconds worth of fuel. And I want to have just a testing amount of fuel, so we're going to put it at a scale of 2, which will give us 50 seconds. Eventually we'll put it at a scale of 0.4, which gives us about 4 minutes total, which I like because it's just a good balance for how often you have to land. And yeah, moving on. So we'll attach the accumulator to the comparison gates, and its input is going to be R2. We don't have to worry about the negative input, we'll have it reset through some other logic in a bit. Then we'll grab our OR gate. That's also going to be set to R2. And that links into the AND gate. And the NOR gate goes into the AND gate as well. Then we'll select one of our comparison blocks and bring its threshold all the way to 100 and set it to equals mode, then connect it to the NOR gate. Then the other comparison gate we're going to set to a threshold of 90, because this is going to detect when we're low on fuel and let us know. So we want it in greater than mode, and we're going to give it a duration of 0.25 and a pause of 0.25, and connect it to our tone generators. So this will make them beep on their own. So we'll select the tone generators and just bring the pitch to whatever you'd like. It's fun to just kind of shift it around. And clear the inputs on them, otherwise you're going to beep every time you shoot. And now to actually wire it in, we're going to select our AND gate and and connect that to all of our main thrusters. So all the same ones that we did for the accumulator on our cruise control. All the ones on the top. And the ones in the back here. Just not the wingtip ones. Then speaking of the accumulator for the fuel system, or not the fuel system, the throttle control, cruise control, that's what it's called. We're going to actually reset this, so instead of having to uncheck all these boxes, we're just going to delete that one, because it's faster to make a new one. Not much faster, but a little. So we're going to do the same thing. Up and down on the D-pad. Minimum of 0. Give it a maximum of 1. And a scale of 50. But this time, instead of connecting it to all the engines, we're going to connect it to our fuel accumulator and the fuel ore gate. So now, everything should be set up for our fuel system, and we can give it a test. Oh, wait, I almost forgot. We need some way of knowing how much fuel we have. So we're going to delete these, and grab a number display, and sneak that in there. Put some 1x2s in for the time being. And in order to get our reading, we're going to go back to our logic and grab an arithmetic block. We'll link our accumulator into that. We're going to bring its constant to 100. And put it into subtract mode. Then connect that to the number display. In this way, instead of counting up to show how much fuel we've used, it'll count down to show how much is left, which is a little bit more handy. I have to thank a friend of mine for showing me how to do that. And now, if the sun wasn't there, you can see that we've got fuel, and we just used a little bit up. Also, our maneuverability is very nice. I'm not sure if I mentioned that before. We should almost be out of our fuel. Oh, maybe not. Okay, we're almost out of fuel now. So our alarm should go off now. And we're still flying. I know what I did wrong. I make this mistake pretty much every time. I did not clear the controls for our thrusters. So we'll select all of our space thrusters and clear their inputs, which is also going to clear the yaw thrusters. But I'd kind of like them to use fuel as well, so we're actually going to modify them a little bit, keep their controls off, and add them to the fuel system. Now we already have OR gates for R1 and L1, so we're going to reuse those. We'll need 2 more AND gates. because our controls have to be L1 on the right and R1 on the left, I'm actually going to quickly swap these two logic blocks to the side just to make them more convenient. Okay, so now they're on the proper side for the thrusters they're going to control. So we'll link this one into the AND gate on the right, then link that AND gate into the space thrusters. Do the same thing on this side. The R1 OR gate into the AND gate, and the AND gate into the space thrusters. Then we'll select our NOR gate, our fuel cutoff, and attach that to both these AND gates as well. So that when we run out of fuel, we won't be able to use our yaw thrusters either, because that's a little bit cheaty, and you can still kind of have a powered glide then. And finally, we want them to actually use up fuel, so we're going to grab 2 more OR gates, put in our controls, R1 and L1, and we're going to bring their output to 0.1, so it's only going to use the 10th of the fuel that the main thrusters do. And we're going to connect that to our accumulator. And now, our fuel system should be complete. So now I'll definitely fast forward through half the flight for us. And you can see if I yaw, it uses just a small amount of fuel, as opposed to the normal thrust that uses quite a bit. But that's because we only have a small amount of fuel loaded right now, so it's okay. And we're almost there. Our low fuel alarm is going to go off right now. And so, yep. Now our thruster's cut out. And I can't use the yaw thrusters either. We're a glorified glider. And I almost forgot a very important part that I always forget till the end. We need a way to recharge our system. So we're going to clear some space there. And put in a distance sensor. And an arithmetic block. Fill in the gap. In the distance sensor, we're going to have an output of -1. We're going to give it a distance of 2, just in case. And connect that to the arithmetic block. The arithmetic block gives a constant 12. And put it into multiply mode. Then connect that to our fuel accumulator. So now when we're on the ground, it'll give us 12 seconds worth, or 12% worth of fuel back every second. And that'll be important because once we put our weapon system in, we'll have our rockets that'll have 12 count, and that'll recharge the rockets entirely. If we had a smaller number, we would have to either have it flicker on and off, or have a blah blah blah. Words. I don't know. Moving on. Now let's do that ammo system I keep talking about. We're going to use most of the same blocks as before. So we'll grab an accumulator. An OR gate. An AND gate. NOR gate, and 2 comparison gates. And we don't need more tone generators because we're going to reuse those ones. That's why we programmed the delay for the beeping into the comparison gate instead of the tone generator. Anyways, we'll also need the arithmetic block and a number display down here. So we'll select our accumulator, give it a minimum of 0, and we're going to give it a maximum of 50. So we'll have 50 seconds worth of ammunition. Make that into both our comparison gates. And put our control as X. Then select the OR logic block. And put its control as X as well. And attach it to the AND gate. Select the NOR gate and attach that to the AND gate as well. Pick a comparison gate. Bring its threshold to 50, not 100. Silly me. Put it into equals mode and attach it to the NOR gate. Then take the other comparison gate, bring its threshold to 40 for the low ammunition warning, set it into greater than, and give it a duration and a pause. For the guns, I'm going to make it a shorter pulse, so it'll be more frantic. If you're about to run out of ammo, that's almost as important as fuel, if not more important if you're in the middle of a fight. And connect that to the tone generators, which are back here somewhere. Then connect the accumulator to the arithmetic gate. Set the constant to 50. Put it in the subtract mode and attach it to the number display. And then we want this system to recharge as well, so we'll grab the arithmetic rate on the bottom and attach it to our accumulator. And finally, we're going to do the logic for the rockets, which we're going to put in the wings. So we'll delete all these 1x2s and replace them with the logic blocks. The same set you're expecting. An accumulator. An OR gate. Just going to put on this side. An AND gate. And an OR gate. And OCD, they have to be facing the same way. It doesn't even make a difference in mirror mode, but it makes a difference to me. And then our comparison gates. We'll set our accumulators minimum to 0. We're going to give it a maximum of 12, because I want 12 pairs of rockets total. And we're going to have this one use steps. And we're not going to put an input into it, because using L2, I've found will put in more or less than, well, not more. It'll put in usually less than a full step, and for our comparison gate trigger, we'll need them in full steps. So what we're going to do is just move on to our OR gate, set that to L2, connect it to the AND gate, and take the AND gate, and I'm just realizing we didn't connect up our weapon system. We made it, but we didn't connect it. I'm an idiot. So you probably already noticed that. So hold your comments, calling me an idiot. We'll select our AND gate and attach that to all our smart cannons. Then select the smart cannons themselves and clear their inputs. So now we'll know that everything's wired up correctly when they fire. So back to the rockets. We'll select their NOR gate and attach that to the AND gate. And then the AND gate is going to get attached to the accumulator as well as the rockets. And that way we have something that'll tick up our accumulator every time while providing a full signal instead of a partial signal. Next we'll attach our accumulator to our comparison gates. And do the same thing you probably expect. Bring the threshold of one of them up to 12, and put it into equals mode, and attach it to the NOR gate. The other one, we're going to bring to 9.9, well, 9 in any decimal, make it greater than, put in delay, we're going to do 0.5 and 0.5, a nice slow beat for this because it's kind of the least important, and attach that to our tone generators. And of course, select the rockets and clear their input. Then we need our display. So we take an arithmetic block and plop it down there, just because there's space. Delete that last 1 by 2. Put in number display in its place. Connect our rocket accumulator to the arithmetic block. Constant of 12. Subtract mode. And put it in there. Then of course on the bottom here we'll take our refueling arithmetic block and attach that to our accumulator as well, because we want to get our rockets back when we land. So now you can see our fuel's ticking down. If we shoot a rocket, that ticks down by 1. And our guns go down 1 per second. So I think we're ready to put a normal amount of fuel in this and wrap things up. So we'll go back to our fuel accumulator, and we're going to bring the scale to 40, or 0.40, and that will give us 250 seconds worth of fuel, which is just over 4 minutes at full thrust. And I found that to be a pretty fun mix of you don't have to worry about it, and you do have to worry about it. But if you're making this system, you probably don't mind the fact that you're going to have to land now and again in the middle of the fight. That's kind of the point. It spices things up. So yeah, let's give it a final test drive. Now you can see the fuel's going down much slower. And if I just spam the rocket button a couple of times... Yep. When we get 2 rockets left, we get our first alarm. And now I can't use the rockets anymore. They're completely out. And the same thing will happen to the guns, and you already saw the thrusters cut out before. So, I believe that's everything. Oh, I should have landed to demonstrate that it does in fact recharge, but I think you can trust me on the fact that it recharges because on the ground it doesn't use up anything. Well, yeah. Anyways, that's everything you need to know, from the beginners to the intermediate to the advanced, on how to build a Kitten Jet Mark 12. I hope you enjoyed the tutorial, and if you learned things, then cool. If you didn't learn things, that's also cool. But thank you for watching. Like, subscribe, and comment if you have any questions. I'll do my best to answer them. Bye-bye now.
PlayStation